Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on October 17, 2025, about 6 days ago. The striking result is that standard decoder-only transformer language models are injective and therefore lossless, and with a new method called SIPET, the exact input text can be reconstructed from hidden activations. The paper is titled, "Language Models Are Injective and Hence Invertible," and as we'll see later, the implications for model transparency and safety are quite significant. It pairs a rigorous proof preserved during training with billions of collision tests showing no collisions, plus a practical linear time inversion algorithm. So the introduction set the stakes. Figure 1 shows that the mapping from prompt space to latent space is 1-to-1, and SIPET provides the reverse path. The left panel sketches prompt space as a surface with two nearby prompts, x and x prime, separated by a small delta. The right panel depicts their images in representation space, two distinct points, z and z prime, with a positive margin epsilon, which signals injectivity because distinct inputs always yield distinct representations. The curved return arrow, labeled SIP, it indicates that the algorithm can reconstruct the exact prompt from the hidden state efficiently. So figure 1 showed a 1-to-1 mapping with exact inversion. Figure 2 illustrates why collisions are rare, because real-analytic functions have zero sets that live on thin curves rather than areas. Left, F1, right, F2, bottom, their difference highlights the zero contour where the value equals 0. Because those contours occupy measure 0, equal outputs occur only on a vanishingly small set of parameters, which supports almost sure injectivity. So figure 2 laid out why collisions should be rare. Here, table 1 reports the smallest distances between last token states across layers and models. The key message is that every layer keeps a clear margin, so distinct prompts stay separated. The collision threshold is a tiny tolerance that marks two vectors as identical, set around 1/1,000,000th. Distances grow from early to late layers, which reinforces separability and deeper processing. So table 2 turns injectivity into practice by comparing inversion methods on the same prompts. SIP. It achieves perfect accuracy and does so quickly, because it tests candidates with a guided search rather than exhaustively checking every token. Brute force also reaches perfect accuracy, but needs orders of magnitude more time. Hard prompts, which tries to recover text by following gradient signals, fails to recover the true input. Alright, 2 takeaways stand out. Standard decoder-only transformers are almost surely lossless because their prompt-to-representation map is injective, and SIPET turns that theory into practice by exactly reconstructing inputs from hidden states. The implications touch transparency, auditing, and privacy, since activations can reveal user text. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.